Hello guys, welcome to my workbench again. I've done part 2 from my valve or tube tester. You can see how far I got. So I'm put all the knobs on, so it looks very nice. Look, show you on the back. What I've done is, I put another potentiometer in between here, on that one here. I put the one here so that I can use those 2 meters. Dus those two as those 2 meters. So what I've done on top is an attenuator of een verzwakker. Attenuator. All the resistors here around it. So you put on 6 volts on this point. And then you can, step by step, you can lower the voltage by half a volt. So the next thing I have to do is to connect all the switches up. It looks like an arduous task, but it is not. So we just have to say, if you go to have a look how it turns. Well, this one is ground. This one is filament. This one is the G1 first grid. This is the screen grid, and this is the anode. And you all just get those. So, and the only what you have to do is next is just connect them all the same way. Connect them all together. Connect them up that way. So you get all those 10. Yeah. If you've done that all together, then the P, I call that the P contact, this side and this side. So we have a look. So we have to use this P contact here, yeah, and that goes then to this one here. See, you can see a small, a mini, a rim lock, an oval, octal, and loctal. So those 5 sockets are put on that. The same goes for this one. You start by 1, you connect up 1, yeah, you connect them all together, and then say go by 2, and so on, and so on, and so on. You connect them all together until you go around. This one has 10. So if you if this is 1, 2, 3, 4, 5, 6, 7, 8, 9, not 10. Yeah. 9, no, that's not the teller, so this is 10. The left is, and that's the count again, 1, 2, 3, 4, 5, 6, 7, 8, 9, yeah, 9 points. So this is only single. Perhaps another socket will come next to it, I don't know yet, if I can find one, that is. And we have to connect that all together. So if if everything is connected up, then you have 5 wires coming off here up to the switches. So 5 wires, so that it will, because you connect them all together, the P1 comes up there. Yeah, the P goes on that wire, it comes here. Yeah, every wire. So say 1 has a wire, 2 has a wire, 3, 4, 5, 7, until 9 or 10, 9 in this case. So what you have 10 wires coming off here, 10 wires what goes up to those connections here. Because you are connected all together the same way, yeah, that gives you the opportunity, turn them around. Say, I will get my book. I'll show you. Get my book. Just take a valve out of here. Let's use this one. They say the EL84. Yeah. We have the connections are 2, 7, 9. Yeah. And the filament is 4 and 5. So what I have to do then is next is 4, dus this one. You put them on filament, that's filament, yeah. Then we get 2. Is that one? It goes 1, 2 filament. That's the grid. Just put that one there. Yeah. Then we have 7. So there's 5. This is 7. This goes up to 2, 3. It goes there. Yeah. And then 9. That's that one here. He goes up to anode max. So then you're all set up. Then you have to put your filament voltages is 4, 5, 6.3, but of course it is 6.3. Yeah, 6.3, and that's about it. And then you can switch them on. Yeah, and then you can adjust your voltage, adjust your voltage on your grid here. Yeah, I'll put them on 3 volts. That's about right here, 3 volts. You can regulate your anode up and you can regulate your screen grid up. And that's actually strict. Then you have your voltage here, your voltage there, and you have a current going. And the current for this anode is 48 milliamps. So he should. How far it goes at 30, 35 milliamps. It depends on what condition the valve is. The valve looks like this one here. That's the valve. There's no valve connection. Yeah, you can even see the impedance you can use for this valve is 5.2K or 7K. It all depends how much comes out. This is 12 watts and this one is 7.3 watts. So no, also 12 watts. So it only depends on the current. 48, yeah, you can see that here is the impedance is about 5.2K. Then the current is 48, and we have here on 7K you have only 4.7 watts, and this is 6 watts. Then your current will be 636 milliamps on your anode. So it is only depending on how you use your valve, but it has nothing to do with this. What I'm telling you now, the output voltage of that valve has nothing to do with this. The only where it has to do with is the amplification factor, and you can find out by decreasing one stop or increasing one stop, and the difference between the milliamps what it takes, what gives you how many milliamps per volt that will be. And the S, that is the amplification factor, is 11.3 milliamps per volt. And it is here, this S is 7.4 milliamps per volt. So there's a difference between it. You can also see this lower because you have a lower voltage, 4.7 watts, and here you have 6 watts. So you see on the amplification factor you can see what that valve is doing. So all this big story is comes down to one thing. You want to know the performance of that valve. You have a given well, information. Let's put it that way. Given information. You can on the whole you can by doing the settings you can see what that valve is going to do. It is impossible to say at this point what it will do. So but later on in this project I will show you different valves. I also have a valve what I know of is not that brilliant anymore, so it is dodgy. So we can see there there's a 6L6 if I recall, 6L6, have a look, hold on, 6L6, 6, hold on, 6L6, 6C, 6L6, see, that one is there. 6L6, there we go. There he is. He has an amplification factor of 6 milliamps per volt. So you can find also here, you see, is 2.5K impedance for that valve, and there's about 6.5 watts which will come out of it. There's an octal connection sensor here, so I'll show you. This is the octal connection for the 6L6, and this one, this valve, is novel, fits in here. See, you start to notice you can put in there what you like, because it's all the same, it doesn't matter. You just put the valve concerns you put in there, and that's it. That's all there is to it. So it will be configured like this. So I built myself some wood to make a box for it, so I put it all in here, and that's how it's going to look, guys. Not another nice sermon, isn't it? Anyway, you can see here I have to connect that all up, so there's quite a bit of work to do here as well. So and that has to fit all together, and it looks very complicated, and it is not. It's not complicated at all. Not to you can, it says 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 corresponds with the pins on the sockets. It's that simple. It looks very difficult, but it's not. So yeah, okay. Enough of my my sermon. I will continue now with the wiring. And occasionally I will put on the camera and I will show you what I've done. So, and that's how we going to proceed. Then something else here, there's a little choke, self-made choke. You need 10 Henrys, something like that. I will show you the schematic of that thing here. There's a very old book, very old. It says, have a look when I put it in. What time that is. Het heet meetapparaten of measure appliances. Let's have a look. One time that is being printed. It's in 1961, so that goes a time back. You can see here the valve, the meters, here, the potentiometers, the choke, the transformer, some diodes, here's the switch. That's the famous switch I'll show you where all the resistors are. That's the switch. That's basically what it is. That is basically what this represents. So only it represents all the valves. Not one. All the valves what you can find in the book you can use. So that's I want to make myself an own schematic on S-plan. So I can find it back. I'll tell you something. I had several measure appliances made myself, because you can find it on the internet, on YouTube. And you think by yourself, oh yeah, but I will remember that. Yeah, you can forget that. I didn't know where I put. No schematic anymore. I had to really look it up. I did search a couple of days to find that schematic. So I learned something from that. So yeah, okay guys. Enough sermon now, and enough talk, enough chatter. I start to get cracking and get this thing on the road. So the sooner we get to the end of this. Okay guys. I will shut down the camera now, and I will come back to you when I'm a bit further, okay? Hello everybody, welcome back again. So I want to show you some things. I wired up the ground, I wired up the filaments. Yeah, I wired that up, and the first cut I wired up. And what we have in our schematic, that we have an attenuator, which is right here. And it's positioned at 6 volts max, and the minimum will be 1 volt. So we're going to show you that it will work with a half volt upwards. So we start off on 1 volt. You can see that here. Start off on 1 volt. I will turn the switch 1.5. 2, 2.5, 3, 3.5, 4, 4.5, 5, 5.5, and 6. There you go. So that's the negative voltage. Well, you say it is positive. Oh, I'll show you something. we'll be negative in a sec. Oh. There we go. Now it's negative. Okay, that's actually the intention. Okay. So we start off at 1 volt, so approximately. So then we go up. So that's about it. Alright, you can see it works. The next thing we have to do is to get our I'll switch that off. Get my start off here, that is the screen grid. Wire that all up along here. Yeah, that way, and come back on that side. Wire that up, and then we wire up our anode. So we have to have, that is my wire. Where is my wire? Oh, there we go. So I will use yellow wire for that. According to the schematic here, that is my screen grid. Alright, that's my anode. So I have to wire that up. There's one of the potentiometers was up here. Yeah. So I have to see which one I'm going to choose. I think I'll choose this for anode, this one for, yeah, it doesn't really matter, does it? So I can choose one of them. So to make up that connection here. So I wire this all up down there, that way back, and I can run wire from here to one of the potentiometers at one of the mid connection, one of them. Okay, that really matters. Another thing was what was going on here. I don't know if you can see it, but this is our P contact to our first grid. That's here. That point. That's one. That's here. But you would have done. You connect it with one resistor up here, and immediately in that switch it makes it short. So you can't do that with that one. So I noticed that, so I changed it all. So the short is gone. So you can see it works from 1 volt. It's in this schematic should be working from a half a volt. So and it didn't work here because it shorts out on contact. That's all. So that was it, guys, for the moment. I'll continue and I'll come back to you. Okay. Welcome back, everybody. So I'm getting on slowly but surely. As you can see in front of you, I put all the sockets in the board. There's in total 7. The mini, the rimlock, the noval, the octal, the loctal. This one I don't know the name of, and this other one don't know the name of it either, so it doesn't really matter. This is 7, this is 8, this is 9, this is 8, this is 8, this is 10, and this is 8 connections. So I will show you what I've done. Turn it round. Oh, yeah, I have to turn it around the other way round, that way. So I was working that way. So you can see what I've done. I will use this screwdriver. Number 7 is here, it's not done yet. Get that one out of the way, yeah. So we have left here 7 and 8, and then we have left here 7, 8 and 9. Then we have 8 left, and then we have a 7 and 8 now I have left, and 10. No, 9, so I beg your pardon. 7, 8, 9, yeah, we have left, and then we have here 6, 7, 8, 9 and 10, and we have here 7 and 8 left. So all I have to do is all get those connections in order, and then we can assemble it. Before I have to do that, I will make a box, say a frame or a box put on. I will show you later on when I start to assemble it, so I have to make that still. So that's how far I got, guys. Yeah, I will shut down the video now, otherwise it will be too long. So I will see you then in the next part. So what I want to do now is to finish this all, yeah. Then I will go outside and saw my my wood to make the box, and glue it all together. I will come back to you. Okay, I'll see you then.